All right, so continuing from our quadratics properties and whatnot, the next thing that you need to know how to do is your domain and range. Okay, and the domain and range, if you just to make sure this is for non-contextual situations, so there's no word problem. Okay? This is going to change once we do word problems. Okay, no words. Okay, so once we get to that, it will change. So domain refers to all permissible x values, right? So if you think of domain, right, you're thinking of the x values. You're thinking sideways, right? So there's two ways to have notation for domain. Set notation. When it's not a word problem, it's just going to be this. X is part of all real numbers, so anything goes. Decimals, it goes to negative infinity all the way to positive infinity, right? Interval notation goes like this, okay? So you go from negative infinity to positive infinity. That's interval notation. So remember that it has the squiggly brackets when it's set notation, and when it's interval, it has the round or square brackets, okay? More about that later, but for now, right, if it's infinity, it's got round brackets, okay? Infinity gets round brackets, always. Okay, so there are your two ways to have a notation. I would definitely say have that on your study sheet. Range, right, range of a function refers to all permissible y values. Okay. So we're talking up and down. So for range, range is a little bit more complicated. Okay. Morning. Range, let me tell you this, it all has to do with the vertex. Okay, you need your vertex to figure out your range. So very important that you always know what the vertex is. So for the range, you need the vertex. Absolute must. Okay. So again, when it's pointing up, this would be your range here. It starts here and it goes to infinity, right? Because this never stops going up. And this is your domain. Okay, so when you have a scenario when it's pointing up, okay, when the curve is pointing up, how do we know that? A is positive, correct? So then you will have the following notation. So when A is positive, so it's pointing up, right? That's this row, this column right here. You will say this y is greater than or equal to the y value of vertex. Okay. So whatever the y values of this vertex you just found, this is the vertex, this is the vertex, okay? Whatever the y values of the vertex, that's the number that you're going to put in here, and make sure you have squiggly brackets when it's the set notation. When it's interval notation, in this case, you're going to start at the y value of the vertex, y vertex, all the way to, it never ends, right at the top, like it starts here and it never ends. So what do you think is going to go here? Positive, infinity, and it gets a round bracket like that. On the other hand, if it's pointing down, right, so in this case A is negative, here A is positive. When A is negative, it's going to be y is less than or equal to the y value of the vertex. So I just shorten it y vertex at this point. Because again, if you want to go up here, this is your range, and this is the domain. And so the domain is like this, keeps on opening indefinitely, okay? I hope you understand that. This thing opens indefinitely. That's why the domain never ends. It's just all real numbers. We did that up here. It goes at negative infinity to positive infinity. But for range, there's going to be a stop either at the bottom or there's going to be a stop at the top. Okay. So when it comes to interval notation for this one, it's going to go, it's different. It's going to go to negative infinity, right? And then it stops at the top, which is the y of the vertex. And remember, for your domain and range, this is for down the road, because then infinities are going to slowly disappear as we do word problems. But just remember, okay, you do smallest first, largest second. Okay? So this is very important that you, like if you kind of figured out, okay, I have my range, make sure the smallest number comes first and then the largest. And you can't really beat positive infinity. There's nothing larger than it, right? So positive infinity should be here. And negative infinity, you can't get smaller than that, so that should be here. And then the y value of the vertex will obviously be the largest number there, okay? Let's keep going. This is going to go to page 8. Let's practice this. And I need you to understand that, and on a test or quiz or whatnot, I will make sure to have the arrowheads there, as well as your x and y axis should all have, I like actually not having it there at the beginning, so you know, okay, I have to add that, so this is your x and your y axis, okay? So if I asked you, what's the domain and range of this? The domain is the easiest part, okay? The domain, when it's set notation, it's just x is part of all real numbers. When it's interval notation, remember there's no word problem here. We're just going to have that notation. Negative infinity to positive infinity. Okay. When it comes to the range, remember you need your vertex. You have the vertex right here. Okay? You have the vertex, and this is pointing down. Okay? So when it comes to set notation for range, you're going to say that y is what? Greater than or less than? This is your vertex. It's just going to be less than that, right? So you're going to go less than whatever the y value is of the vertex, 2.749. Okay? That's the set notation. When it comes to interval notation, we're going to say that we have this, the largest value is going to be 2.749. That gets us square bracket. And the smallest value, remember, it goes down here, it's going to be negative infinity. Round brackets. So maybe I'll do this. For your range, you always want to see, this is where you see the graph. So it starts here, and it keeps on going down indefinitely, right? This is your range. And for the domain, you're going along the x-axis, and it's all of it, right? All of it. Because this thing keeps on opening indefinitely. You want to give this one a try based on the notes I just gave you? State the domain and range of this thing, and remember, there are arrowheads, because this will, at one point, the arrowheads will stop, right? So we're going to explore, you know, something being thrown off from the ground, and then that object hitting the ground. So we'll have points where this ends. There are no arrowheads, okay? So just get comfortable with this. What is your domain, and what is your range? The vertex, in this case, you should be able to estimate that just by looking at the graph, right? The coordinates of the vertex, you should be able to just look at this and figure it out. Give it a try. Okay, let's see. For the domain, not much to really think about there. it's this, and then it's this. That doesn't change. For the range, maybe on your study sheet you should have a range when it's pointing up. First, you need your vertex. And the vertex right now is 5, 1. Okay? That's the vertex. Particularly, we need the y value of it. Okay? So in this case, y is going to be greater than or equal to 1. Okay? And here, it's pointing up. So 1 is the smallest value, which gets a square bracket attached to it. And then it keeps on going up indefinitely. So it looks like this. It goes from 1, right? In terms of y, it goes from 1 all the way to the top. So maybe just for the range here, I like to have, right, we start here, and then it goes up. Right? Okay, so that's how range works. Range is for right now the hardest probably. This one is pretty much close your eyes and just write it down. In terms of, will I make you use one over the other? No, I won't make you, but I may give you a multiple choice question where it's like, hey, this is a graph. What's the correct domain or range? And I may use any format. You should be able to read it and understand it. Okay. Let's keep going here. We get to the part, we ended here last lesson, and we just talked about at first, we were able to fill in for sure the first 3 things, like what the form was. We knew it's general, there's no brackets. Which way was it opening? The width. And we also could figure out the y-intercept because it's in general form. We know that that last number is the y-intercept. Okay. Now, for the rest, you need your calculator. Okay. So we're going to spend a little bit of time figuring that out first. So what I'm going to ask you to do is, I'm going to ask you to go to the very front of your booklet because this is so key, using your calculator, right to the front. That's why I left that blank there. I need to erase that pi there. That was the talk I gave you about time, right? Okay. All right, so your calculator has something. I access this setting second, and then I press trace. It was dry there, so good luck out. Second trace, and then we have some options. You have a menu. Okay, so I want you to press that once before I start talking about it. So remember, if you press any button and you're like, oh my goodness, where am I? Always go second, quit to get you back to the home screen. Okay, so don't panic. I want you to go second and then press trace. Really what you're accessing is calculate. Okay, so anything to do with the graph, guys, is up here. Anything to do with a graph, those functions are up here, but we're going to go second trace. And then you see a bunch of options here. We are only going to use value, minimum, maximum, and intersect. Okay, those are the only ones that we're going to access here. So value, the first option here. What does it do? Okay. So this option right here determines the y value if you know the x value. Okay, that's what it does. Determines the y value if you go the x value. So basically, if you know that x is equal to 3, let's say, and you don't know what the y value is, you want to be using this function right here. Okay. It also, so I'm going to branch off of it here, very useful to find the x-intercept. What is the equal to at the, sorry, y-intercept, my bad. Y-intercept, sorry about that. What is the x value at the y-intercept? X is equal to? Always 0 because, okay, here. What's the y-intercept? The y-intercept is any point along the y-axis, right? That's where the line crosses it. We know that any point here is going to be 0 and then something, right? A number, whatever height you're on. Okay? Got it? So that's what we're going to use that function for. The next one we're going to use is this one, the minimum. Okay. This one finds the vertex if parabola opens up. Okay, so in other words, A is positive. So if it's pointing this way, this is the vertex, right? And at this point, it is the minimum. It's the lowest point. So you're going to use this one if you want to find the vertex of a parabola that's pointing up. Guess what? 4 is maximum. Guess what that does? Finds the vertex. If parabola opens down, okay? In other words, A is negative. Right now it may seem overwhelming, but after a while you're just going to be champs, you're going to be pros here. Okay? Because then the vertex happens to be the highest point. Okay? So you got to use that one for. So you will never have to use both at the same time. It's either going to be minimum or maximum depending on the situation. So that's going to find us the vertex, which is very, very important to us. Okay. And I'll show you how to use that. Next one is 5, intersect. These are all the functions that I use. Okay, I don't use any other ones. Intersect. What does this do? It finds the point of intersection between two lines or curves. In particular, and for us right now, okay, if you have a parabola like this, and we draw a horizontal line like this, we'll put this parabola might be in y1, this straight line might be in y2. So if you want to find these coordinates of these 2 points here, it's going to find those for you. Intersection. So these are the ones that we're going to use to navigate almost anything. Okay, I will tell you this. I use this one. Well, maybe I'll just show you how I use it, and then to find the. I will add that here. It's very important. We use this to find the important x-intercepts. So basically, example, what is the y value like at the x-intercept? X-intercepts are here, right? What's y? 0. So it's going to be a number 0 and a number 0, but y is always equal to 0. So to use this guy right here, we let y2 equal to 0, and then you will find out later on. I'm just going to go dot, dot, dot. So I'll use this to find the x-intercept as well. So right now this may not make any sense to you, but once you've tried it out, you will probably come back to this and it will make a bit more sense to you. So this is what we're going to use today. This is what we're going to try and master at the end of today. Okay. Let's keep going. We're going to go to page 9 now and put this to the test. So you got to be able to graph on paper, but before we do that, we have to figure out the information here. So I don't care if you've mastered this already. I want you to all enter this again into your y1. Press y equals. I still have mine there, so I'm good to go. We're going to hit graph. And if you want to see exactly what I'm seeing, I have this in my X-min, X-max, right down here at where my pencil is, and Y-min, Y-max. So if you want to see the exact window that I'm looking at, you want those entries in your window. So you go to Window, and you change these to what I have, and then you're good to go. All right. And part of showing your work in this course, guys, is you got to tell me your keystrokes. Like, what did you press to get there? And it doesn't have to be exactly like I have it, but some sort of indication that you've done that. So to find a vertex, in this case, it's pointing down, right? So this is going to be a max, right? That vertex is going to be the maximum point for us, the highest point. So you're going to use second, trace, and then we're going to say max. Okay? For these to work, it is extremely important that you see the graph. If you cannot see it, it's not going to work for you. So hit graph. Should be able to see it. Now we're going to go find that vertex. We know it's somewhere where my pencil is, but please don't guess. Guessing is not good enough. You have to be exact. So you got to go second, trace, max, so maximum, right? Hit enter. And don't hit enter again, but watch what it says. There's a prompt here. It says, give me the left boundary to the vertex. So if this is the vertex where my pencil is, it's basically asking you go to the left of it. So go arrow left. Keep pressing until you get to the left of the vertex. So the cursor should be somewhere in there. If you press a button by mistake and it's no longer there, like let's say I press 2, it's gone now. So you got to just redo it. Second, trace, max, right? Redo it. And if you don't see it, if the cursor is off your screen, it could be that it's way like out of sight. You got to look at these coordinates. So if I go to the right, I can see that this thing is going up. And there it is. It shows up there. So sometimes that will happen to you. Anyways, this is your vertex. You want something to the left. That's what this is asking. Hit enter. Anywhere to the left. It doesn't matter. Hit enter. What does it ask for now? A right boundary. So you got to go over the hill, somewhere to the right of the vertex. And Mr. Dirksen, does it matter if it's here, if it's here, if it's here, if it's here, if it's here? It doesn't matter as long as you are to the right. I'm going to go a bit closer because it's just going to be like a microsecond faster if it's closer. That's all. See how you've now told the calculator the vertex is somewhere in between these two lines. When it says guess, this calculator is just saying, can I start looking for it? Just hit enter. And it should stop right where it's supposed to be. Okay? So that's your maximum right there. So these are the coordinates of the vertex, x, y. So write those down. 25. We round to 2 decimals. But this would round to 0.00, right? So I'm not going to bother. This is a 112.5. Okay, you got that? Do you remember the axis of symmetry? I know it's fairly new here. Do you remember that these two axes of symmetry and the equation of min and max can be just taken from your vertex. Do you remember that vaguely? What are you talking about? I just want you to go to page 5. This is what I'm talking about. The vertex provides us with two additional pieces of information. The axis of symmetry, which is that imaginary line that cuts the parabola in half, right? And so this is the x value of the vertex is going to be there. And then there's a horizontal line that goes through the vertex also, which is given to me by the y value of the vertex. Okay? That's all it is. That's all it is. So when we go back to 9, AOS is simply 25. X is 25. It's an equation. This is an equation, okay? Equation of min or max. It has to say it this way, but we know that this is the equation of the max, right? In this case, y is equal to 112.5. So this is something you're just going to have to get used to. But both of these lines, right, they make a T right through the vertex. Okay? X-intercepts. Let's find those. What function do I use for x-intercepts? I don't know if you look at the front of your, if you just go to your cheat sheet for now, we use this one to find the x-intercepts. You find that fifth option. So this is how you do it. You let y2 equal to 0. And then we're going to go second, trace, I hope this fits, intersect. I can never make it. I don't know. It's always been my life struggle. I always think I have enough room and then it doesn't work. Grab your calculators, please. So watch what we're going to do. We're going to say the x-intercepts are here and here, right? So we're going to trick the calculator. We're going to say, let's graph a line, y2 is equal to 0. That's a horizontal line, folks, okay? Hit graph at that point. And you have a color screen. It used to be very hard to have students understand this because it was just black and white. But you see now that we've sketched a line right on the x-axis, right? So we're going to find the intersection between the blue and the red here, and then we're going to find the intersection between the blue, which is our parabola, and the red here. And that is effectively going to give us our x-intercepts. Okay, so you're going to have to do this twice. Second, trace, intersect, or you press 5, whatever works for you. And it doesn't matter which one you do first. I'm closer to this one right here. So if you're close enough, watch. This is close enough. You don't have to be right on it. Even this is close enough. You hit enter 3 times. So enter, enter. And when it says guess, it's like, can I start looking for it? You say yes. And there it is. The first x-intercept is 40, 0. I'm going to write that here. Let's try one more time. Second, trace, 5. Now we want to find this one. So I'm going to travel on the blue line. You happen to be on the blue line. Get to this side. Once you're close enough, that's good enough. And then you press enter 3 times. Because it's basically asking you, hey, give me the first curve you want me to consider. You hit enter. Now it's saying, give me the second curve that you want me to consider. You are on it. It's the red one. And guess, just keep hitting enter there. And so now you found that it's 10, 0 for my second x-intercept. These could be decimals, okay? So don't think that's always going to be nice and pretty numbers, right? It's not always the case. Okay, I'm going to highlight these ones. These are the hardest ones to find. After a while, you're going to be champs, right? But this one we use that calculator for, the x-intercept, as well as the vertex. And that's going to be the case most of the time where you're going to have to use your calculator to find the vertex, to find the x-intercepts. What about the y-intercept? We didn't have to use our calculator, but you can. Watch this. The y-intercept is somewhere here, okay? We use this function. It's always second trace. Press second trace. I use value. I just want you to know how to use it. Value. What is the x value at the y-intercept? 0. So hit 0 and then hit enter. It goes right to where the y-intercept is. And what is it? Negative 200. So if you're ever not sure, just use the calculator. Okay? Because I won't know. I won't know any better. So if you use the calculator, just say it's second trace value x is equal to 0. That's all I need to see. And then you're good to go. So since we used our calculator, I'm not going to highlight that as well. So those are the 3 items that you must have to graph a graph properly, to sketch it properly. How about we do the domain and range as well, and then we basically have all the characteristics of this graph. The domain is easy. It's just x is equal, is part of all real numbers. Or you could go negative infinity to positive infinity. What about the range? It's pointing down, right? So set notation, y is pointing down. So it's less than or equal to. We always go to our vertex for this one. Less than or equal to 112.5. This thing never goes past the vertex above it. Or, this one is always tricky. So you're going to have a good study sheet for this one to help you out. This would be negative infinity all the way to 112.5. Square bracket. And you're going to have to practice that. That's just how it goes. And what I'm going to do is, before I actually sketch this on paper, I want you to try finding these by yourselves or with your partner. I'm fine with either one. I want you to fill in this entire table using pages 10 and 11 before I sketch it. I'm going to show you how to sketch it shortly, but I first need this filled out completely before you do that, okay? So I'm going to let you struggle with it a little bit. Step number 1, guys, type this into your calculator. Step number 2, make sure you see this on your screen. If you cannot see this on your screen, you're in trouble, okay? So maybe that's going to be a bit of a struggle for you. I don't know. I don't know what's going to be it. So I'm going to try to figure it out, try to help you out. And fill in this table on page 10 as well as 11. And then I'm going to show you how to sketch it on paper. Okay? Can we do that? And if you can't do it, I'm here to help you. Okay? And I'll post a key as well. Maybe not right away. So if yours is very slow, this is what you do. You go... give me 1 second. Second window. No. Second zoom. Yeah. Second zoom. But if yours is fast, then don't do anything. Okay? Basically, you just want to make sure the very bottom of this, detect asymptotes. You want that to be turned off. If it's on the on setting, then it's going to be very slow because it's always trying to detect it, and it's not. That's why it's slow. It doesn't make a big difference. It's still you're gonna be all right. But if you want it to be faster, then that's what you do. So people on the video have this as well. This is page 10. Make sure you fill in that. This is page 11. See if you figure that out. I want to show you how to graph on paper. So the only thing over the break that I'm going to ask you to do is to try to graph this on paper. Okay. So let's go to page 9. And I want you to, maybe you need to have this on your study sheet, but a good graph, right? This is even for grade 12. A good graph should have the following, okay? For a graph, you should include all intercepts. if there are there, because there aren't always x-intercepts, right? Sometimes we don't have any, but most of the time there are. You want to make sure you include the vertex. You want to make sure you have an appropriate scale. And I'll show you how to do that, appropriate scale. You want labels. So basically, equation and the axis needs to be on there, okay? As well as arrows. So for this one, you have to have arrows because it's not a word problem. So that is a must for a good graph. If you want to get 3 out of 3 on a graph, then I'll be looking for all of those things. So let's do one here before we go. So I'm going to go up here. I'm going to zoom into this section here. So I was nice to give you a grid. You won't always have a grid. So arrowheads on all the axes, right? This is Y, this is X. First thing you need to look at in terms of your X, you look at your x-intercepts. What are my x-intercepts? What are they? 10 and 40, correct? So you use something that works for you. So I'm going to say, I'm going to go up by 10. As long as you're consistent, you're fine. So I'm going to call this 10, 20, 30, 40. So it's very easy on this grid to do it, and we'll do a couple going into the negatives. Boom, you got it. You know your x-intercepts are going to fit. Now, we need to look at the y. And you look at your vertex. Where is it? It's right here. I need to go as high as 112.5. Right? That's going to be the highest because it's pointing down. So you need to allow for room here. So I will do this. I will go 50, so 50, 100, 150. Is this okay to have a different scale on the x-axis? Yes, as long as it's consistent. Okay? You can't say, you can go up by 50, all of a sudden you go up by tens. That's a no-no, okay? So we're going to go negative 50. Oh, what else should I have looked for? Where does it cross here? What do we call that? The y-intercept, right? I need to go as far down as negative 200, and it's going to work out for us. Just barely, but it's going to work out. And remember, you use pencil and you have an eraser, you may have to start over. That's okay. So we've got our scale figured out. We looked at the x-intercepts, we looked at the vertex and the y-intercept. Now you just plot them. You don't, if they show up here somewhere, you just have to plot them. So 10, 0 is right there. 40, 0 happens to be right there. And not always will it fall right on it, right? Sometimes there will be decimals. You can expect all of that. Let's go and plot this one, 25, 112. 25 is in between 20 and 30, right? Right there, so I go up to 112. So for me, 112 is right about there. And I'll tell you a secret, close enough is good enough. Like we're not going to split hair, but it has to be within that range, right? 100, this is 110, 120, 112 is just above the 110 line. And you plot your y-intercept right here. So we've got our intercepts, our vertex. We're good. And so this is where art comes in. So you want to go light first. You want to connect them, and you want to go through these points, and then you want to watch this. When you get to the top, you kind of want to curve as you get to the top. You don't want to go straight to it because that's a V. You don't want a V, okay? So you kind of curve it as you get to the top, and then you make a copy of it going the other way. So I go to the top, and you go the other way this way, and you kind of want to try to make it look symmetric. Okay, meaning they should look, if you cut this in half, you should have the same on both sides. The distance should be the same from the middle. Make sure you have arrowheads on this curve on both ends. And last but not least, you have your equation, which is y is equal to negative 0.5x squared plus 25x minus 200. Oh yeah, sorry. So, hold on. I want you to try 9 to 11 where you have a nice grid, plus pages 28 to 30 where you don't have a nice grid. How am I going to do that, Mr. Dirksen? No worries, I'll tell you how you do that. So make sure the whole thing is filled in, and I'll post the keys. I have them ready to go. I loaded them this morning. If you go to 28, don't pack just yet. Oops, I was off by a page, right? I moved it. I should stop making changes. 29 to 30, sorry. 29 to 30. Make up your mind, right? You have these ones. Watch this. Do you see something cool up on the corner of this thing? There's a QR code. Hey. So if you scan that QR code, it's a video going to the entire thing, actually graphing. So if you cannot do it by yourself, I'm there to the rescue, right? 24/7, the whole spring break, okay, to help you out. I can't emphasize enough how important it is to be really good at graphing and to be really good at putting this in your calculator, finding a good window, finding the intercepts, the vertex. This is really, really, really important. Not just this year, next year. So please take the time to do this. That's why I wanted to get started on this before the break, so you have a little bit of time, because I know this is a lot. I know like I'm bombarding you with a lot of information, so you need some time to just sit down and figure this out, okay? Thank you guys. Have a good break.